Okay, ladies and gentlemen, this is Unit 7, Note 6, mutually exclusive and inclusive events. So what you're talking about mutually exclusive are two things that cannot happen at the same time. So if I flip a coin, it cannot land simultaneously on heads and on tails. Inclusive means you can be part of both categories. So if I said you're going to draw a red card or a king, well, you can be both a red card and a king, so you can be part of both categories. So that's kind of the big difference that you're looking at. So if I say a bag contains 8 red marbles, 12 blue marbles, 9 yellow marbles, 11 green marbles, a marble is drawn at random. Find the probability that it is blue or green. So blue or green, you're not going to be both, okay? You're not blue and green at the same time. You're either blue or you're green. So if I've got my marble bag here, I've got 8 red, 12 blue, 9 yellow, and 11 green. So that's going to be a total of 40 marbles. How many of them are blue or green? Well, I got 11 blue, or 12 blue and 11 green. So that's going to be 23 out of 40 marbles. So mutually exclusive are going to be events that don't affect each other. Inclusive means events that do affect each other. So all you do is you add the two probabilities together. If you have something that affects each other, you take the two probabilities, but then you subtract the probabilities that are in common because you ended up counting them twice. So let's take a look. Determine if the events are mutually exclusive or inclusive. Drawing a heart or a diamond from a standard deck of cards. Well, you can't be a heart and a diamond at the same time, mutually exclusive. Drawing an ace or a spade from a standard deck of cards. You can be an ace and you can be a spade. Case in point, the ace of spades. So the probability for this one's going to look like this. Probability of drawing an ace is 4 out of 52. Probability of drawing a spade is 13 out of 52. But I also need to now subtract 1 out of 52, okay, because there's one ace of spades. That card got counted twice. It got counted here as an ace and it got counted here as a spade. So I need to take care of that by subtracting it. So that's how I'd figure that out. Okay, rolling a 5 or a number greater than 3 on a dice, that's going to be inclusive. Picking a red or blue M&M out of a bag of M&Ms, that's going to be mutually exclusive. So one teacher must be chosen to supervise a senior class fundraiser. 12 math, 9 language, 8 social, 10 science. If a teacher is chosen at random, what's the probability that teacher is either language arts or social studies? All right, we're going to pretend that there's people that don't teach both, and we're going to say that that's going to be mutually exclusive. So the probability that you are a language arts teacher is going to be 9 out of, let's see, 12, 9, 8, 10. So 12 and 9 is 21, 8 is 29, 10 is 39. So probability of a language arts teacher is 9 out of 39. Probability of a social studies teacher is going to be 8 out of 39. So when I add those two, my probability is going to be 17 out of 39, or not quite 50%. So suppose that out of 1,400 students, 550 take Spanish, 700 take biology, and 400 take both. What's the probability that a student selected at random takes Spanish or biology? So this is going to be inclusive. Why? Because you can take both Spanish and biology. Even they tell you 400 kids take both. So you want the probability of finding a Spanish kid. And that's going to be 550 out of 1,400. Then you want the probability of a bio kid. That's going to be 700 out of 1,400. And you're going to add those two, but you're going to subtract the 400 that take both. So 550 plus 700 minus 400, that's going to be 850 out of 1,400 kids take Spanish or biology, or both. So 2,400 subscribers to the internet service provider, 1,200 own HP, 500 own Dell, and 100 own both HP and Dell. What's probably a subscriber selected at random owns either one? Well, some people own both. So you want 1,200 of the HP guys. Change color here so it's a little bit easier to see. So that's your HP guys, plus the probability of your Del guys, which is going to be 500, minus the 100 that own both. So 1,200 and 500, 1,700 out of 2,400, minus 100. So that's going to be 1,600 out of 2,400, which is a really, really fancy way of saying 2/3. All right, 4 algebra books, 3 lit books, 2 bio books on a shelf. A book is randomly chosen. What's the probability of selecting a literature book? All right, you can't be both literature and biology, or you can't be algebra and literature. You are one or the other. So 4, 3, 2, there's 9 books total. A lit book is going to be 3 out of 9. And the algebra book is going to be 4 out of 9. So together, the probability of choosing one of those is just going to be 7/9. So game of bingo, balls are numbered 1 through 75. These numbers correspond to columns on a bingo card as shown in the table. Numbers selected at random was probability that is a multiple of 4 or is in the 0 column. So a multiple of 4, this is supposed to be of 4, not or 4. Multiple of 4 or in the O column. That means you're in this category. So multiple of 4. So you got 4, 8, 12. First off, this is going to be inclusive because you're going to have groups in both. So you have 16, 20, 24, 30. Then you have 36, 42, 40, 40, 44, 48, 52, 56, 60. Then you're going to have 64, 68, and 72. So there's all your multiples of 4. So your multiples of 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you got 17 multiples of 4 from 1 to 75, plus everything in 0, which is 61 to 75. So that is going to be 61 to 75. That's going to be 14. Minus 1, 2, 3, because those 3 got counted twice. So 17 plus 14 is going to be 31. Minus 3 is going to be 28. There's your probability of getting one of those guys. All right, card is drawn from a standard deck of cards. What's the probability of drawing an ace or a face? Face cards are Jack, Queen, King. So you can't be an ace and a face, so that's going to be mutually exclusive. There are 4 aces. There are 1, 2, 3 face cards times 4 each, so that means 12. 52, 52, 52. 12 face cards, so that's going to be 16 out of 52. A little division, that's going to be 4 out of 13. That would be your probability of drawing either an ace or a face. All right, so don't forget to do your homework. You can do it on Schoology. You can do it on Notability, but you have to get it done and show it to me and make sure that's all correct. All right, thank you for playing. We'll talk to you soon. Have a good